There's a museum with two counters. The first one is sensing how many people have entered the building since the start of the day. The second one is sensing how many people have left the building since the start of the day. Each counter's value would be represented by the function f and g. So let's let f be the number of people that have entered the building since the start of the day. What could that function look like? Well, at the beginning of the day, the initial count is 0. Then someone walks in and that count rises. And people continue to flow in and the count continues to rise. Perhaps there's a point in the day where no one else is coming into the building, so that could be represented by a flat line. Will the value ever drop? No, because this function is only measuring how many people have entered. It doesn't subtract from the number just because someone has left or because people aren't coming in anymore. So this function f is always increasing. There are different rates of increase, but it is always increasing. What about the second sensor? We can call that function g. What could it look like? Well, it would also start at 0 because no one has left yet. Then as people enter, they will start to leave. And so as people enter the building, now the g function starts to rise as well. Now, is it possible for the g to ever be greater than the f value? Think about that. Can the number of people that have left the building since the start of the day be greater than the number of people that have entered the building? Well, you'd have to create some ghosts that were in the building in order for that to be ever true. So G, for real people at least, will never be greater than F. So we'll draw a fictitious G, and as you can see, it's also an increasing function, but there could be a period of time when no one is leaving. That would represent a flat line. This should be a flat line. Shouldn't look like it's decreasing. Let me fix that. Okay, so it's always increasing, but then there could be a period of flatness, and then it can increase again. And every time the value of G equals F, we know that the total number of people that have walked in equals the total number of people that have left, which means the museum is empty. So at these points where F equals G, our museum is empty. It can also happen in the middle of the day. Let's say there was an evacuation. So here we see a very close proximity. This could be a moment when they had to evacuate the museum. Maybe there was a fire alarm and the only people in the building are the professionals, the firefighters or whoever is in charge of that drill. Okay, so now that we understand F and G, how can we discern the total amount of people in the building at any given moment? This axis here is time. Well, it would be the total inflow. That would be F, total inflow, total number of people that have come in since the start of the day, minus the total number of people that have left since the start of the day. That will give me the number of persons in the building at a given time. Okay, now that is represented by the difference between F and G at any given time. So you can see that even though F and G are always increasing, the values of F minus G go up and down. Now, I could do the tedious job of plotting f minus g. That is very tedious. Or I could use the information that I've been given. I actually was given in this problem f prime and g prime. So even without knowing f and g, I know that I can get a maximum by finding the critical points. That is the zeros of the first derivative. So f minus g, which is total inflow minus total outflow, gives me the value that I'm interested in. The y value here would be the number of persons in the building. To find the maximum of y, I simply look for the critical values of the derivative of y. Okay? Y prime is equal to this. Now, you will have to test the left and the right side of the critical values to see if you have a positive to negative transition. So you want a positive y prime on the left and a negative y prime on the right of your critical point. Okay, that will tell you that you have a maximum where the slope is 0. Remember that when you have the valley, your slopes do the opposite. They go from negative to positive. And remember that this is referring to the difference of f minus g. The y value here is defined as f minus g. Now we talked about how to get this 0 point easily using your calculator. You need to be able to do the intersection function or the 0 function on your calculator. Okay. That means that you're going to have the intersection function. You're going to have 2 functions in your y editor. Y1 could be the f prime, and y2 would be the g prime. And then you can find the intersection of those 2 functions. Okay. You would need to do a guess a certain x coordinate, and then it will find the closest intersection. You also have the 0 function on your graphing calculator. In that case, you would use this full expression in the y editor. You would let your y editor equals f prime minus g prime, and then find the zeros. Well, I hope that was helpful to you. Thanks for listening.